So welcome everyone. My name is Lindsay Speer. I'm the campaign manager for HeatSmart CNY and I work for Alliance for a Green Economy. Our campaign is in partnership with the Central New York Regional Planning and Development Board, and we're funded by NYSERDA, the New York State Energy Research and Development Authority, to help people understand geothermal and air source heat pumps and other heat pump technologies as a key technology for a renewable energy future in New York State. We also focus on energy efficiency because the best energy savings we can get are from the ones that we don't use. And we'll be going into a lot of different pieces tonight. I want to start by just acknowledging that I'm here in Syracuse, New York, and on Onondaga Nation land. And I always start by thanking them because I started my work as an environmentalist working with the Onondaga Nation closely. And it was through the Onondaga Nation that I first learned about geothermal heat pumps when they installed them in their new fire barn. Their environmental stewardship is always inspirational to me. So on the phone with us, or on the webinar with us, we have our 5 installer partners through the HeatSmart CNY campaign: Halco, Snug Planet, ACES Energy, part of the Ground Up Alliance. We have Simply Installs and NP Environmental. And I want to thank Andra Lemanis, who's my colleague with Alliance for a Green Economy, who is doing the background tech support on this meeting for today. So happy Earth Day, everyone. Tomorrow is the 50th anniversary of Earth Day. And that's really something. We've come a long way in 50 years. That started so many of our environmental laws that have done so much to help clean up the environment. So we no longer have burning rivers, and the air quality around us has improved dramatically. At the same time, we're seeing a lot of those laws being gutted, not just in the past 4 years, but over time. And it's worth thinking about. But there's a lot of progress, and heat pumps are a key piece of the progress moving forward. So I'm going to start with an introduction to the HeatSmart campaign, kind of talk about why this is important in the big global sense. We're going to talk about home performance improvements and energy efficiency. We're going to talk about heat pumps and introduce you to how they work, and particularly in these cold climates. Along the way, we're going to talk about some examples and what next steps can be, particularly in this time of COVID-19. We are clearly doing this online today because we can't do this in person. This was meant to be a workshop in Cazenovia tonight, and this is where we're at. We're doing webinars. And in a time of economic downturn, it's certainly something we've been thinking about. You know, who are the key people for whom these programs make the most sense? And I want to just kind of highlight some people. So if you see yourself in these people that I've listed as audiences, pay particular attention. I think some of you will find, I think everyone will find themselves somewhere. The first bullet point is for people who maybe are relatively economically comfortable in these times. Maybe you've retired already, and you want to be doing what you can to help the economy recover. Improving our energy efficiency and our homes is part of how we do infrastructure jobs. And we have people who can't go into the homes right now. Our installers can't come into people's homes, but they can do a lot of background work and do a lot of the figuring out about what systems might be best for your home. And so by lining up projects that can roll as soon as we can get back into people's homes, this is a way of keeping jobs for upstate New York residents. For people whose heating systems might be impacting their respiratory health, this is also a key time to be thinking about that. COVID-19 is not going to disappear entirely. And our respiratory health for all of us is very important. For people who are down on their luck in this time, they may now be newly eligible for low to moderate income funding, which there is a plethora of in these programs. And then for people thinking the long term, who are looking at the renewable energy future that is coming, and wanting to plan for it in terms of their energy expenditures in their homes. Anyone who's planning new construction still certainly needs to be looking at this. Our energy system is changing. And commercial and municipal buildings, especially if they're sitting empty right now, this is a great time to be making some improvements. Soon will be a great time. So the HeatSmart CNY campaign is one of 14 currently and soon to be 20 clean heating and cooling community programs across New York State funded by NYSERDA. And some of you may be joining from areas outside of our territory. We are covering Oswego, Onondaga, Madison, Cortland, and Cayuga counties. But if you're joining from other communities, most of what we're talking about tonight is still applicable. So we wanted to make sure that you're aware of that. And we'll have contact information at the end for each of these communities. Our campaign launched in the fall of 2018. We have a great steering committee. We've had great bunch of volunteers working with us. To date, we've had over 20 open houses, 20 presentations, lots of tabling, lots of going to other people's events and getting the word out. To date, we have had 800 people reach out to us for more information on heat pumps. And we've had 67 homes improved with heat pumps and insulation and air sealing. These are some of our open houses that we did. And you can see smiling people with their heat pumps. It's a series of pictures I've been trying to keep going because it's a little bit hard to be excited about HVAC equipment. I am now, but the pictures are a little bit fun. So smiling people next to their equipment is always great. And if you have a heat pump and you want to take a picture next to your equipment and send it to us, we'd love to feature it on our social media. So HeatSmart CNY in these times of the, why is this globally important? This was from December 6th, 2018, Washington Post. Their opinion, it's time to face the inescapable truth. We're running out of time on climate change. And they noted that there's a surge in emissions in 2018 due to likely higher energy use being used to heat and cool homes. As global warming increases, we are seeing people want to use their air conditioners more. And we're also seeing, colder periods too, as the global climate changes and things get more strange. And so we can do our part for averting climate change by looking at what we can do in New York State to reduce our greenhouse gas emissions. And this is a really key slide. This comes from the New York State Department of Environmental Conservation, looking at the contribution of various sectors in New York State. Now, clearly transportation is by far the largest sector that contributes to climate change. And it's very interesting these times to see how the elimination or extreme reduction of cars on the roads has really improved air quality around the world in this temporary time. But next on the list is buildings. And 30% of our greenhouse gas emissions in New York State comes from on-site combustion in buildings. And the only way to address that is building by building, house by house, business by business. 90% of our buildings in New York State heat with fossil fuels. Now, we are lucky in New York State that we have leadership that is truly taking a lead and setting good targets. First, they were targets and goals put forth by the governor. And then last year, the residents of New York State and our legislators came forward and put together the Community Leadership and Climate Protection Act, the CLCPA. And that is committing us to reducing all of our emissions across New York State by 40% by 2030 from 1990 levels, 70% renewable energy by 2030. And then this is a key part here that really influences what we're talking about, 600 trillion BTU British thermal unit increase in statewide energy efficiency. This particularly is looking at that 30% of the greenhouse gas emissions that come from our buildings. And so New York State is actually putting substantial resources to address this and help its residents make the transitions that need to happen. So how do we meet our greenhouse gas goals? How do we contribute in the way we want to? There's greater minds than mine that have been doing a lot of work to understand our energy systems. And the mantra that's coming out is beneficial electrification. Basically taking this, what we are currently combusting our fossil fuels for and turning it over to clean electricity. Now, our energy system isn't fully clean at this point, clearly. But in New York State, we're doing pretty well, and particularly in upstate New York, only 10% of our electricity every year comes from fossil fuels, interestingly. 40% of that's from the hydroelectric plants. We've got 10% from renewable energy. And so already our electricity makes us one of the better places for beneficial electrification. So you can see on this graph, even just plain switching our cars, our homes, our combustion to electricity makes an automatic 50% reduction. And then as the grid gets greener, as we get more renewables powering the grid, as we put more solar panels on our homes, all of that, the emissions decrease. There's no way for combustion to decrease that. But when we're burning fossil fuels, we are automatically creating greenhouse gases. But with the greening of the grid, our energy efficiency increases the more we electrify. Now, anyone who lived through the oil crisis is probably thinking electrification, oh, baseboard electric, oh, wait. We're talking about something different. But the first thing we're going to do is talk about energy efficiency in our homes and improving the home performance. So I'm going to turn this over to Dick Kornbluth, who is our home performance expert with the HeatSmart CNY campaign. And he has spent his whole career working on improving people's homes and is now retired, is lending his expertise to us. So Dick, are you ready?
Yeah, just stay on this slide for a second. I just want people to notice in the image that you see warm air leaking out the top of the building and cold air leaking in the bottom of the building. This is due to natural forces that simply exist in every building called stack effect, and it accounts for most of the air leakage that occurs in buildings that takes energy out of your house. Next slide. Next slide, thank you. Most people think of insulation as just having to do with saving energy and reducing their utility bill. But there's actually an approach to energy efficiency which addresses the whole house. And so it doesn't just address the fact that you're burning fossil fuels and you want to reduce your consumption of fossil fuels, but it actually addresses the comfort and durability and health issues that occur in everybody's house. And this is just a list of the kinds of things that a home performance contractor will actually address when they treat your house. If you have moisture problems in your attic or basement, if you have poor indoor air quality, if there's excessive dust, if you notice that there's dust settling on your furniture, or you have condensation in the wintertime on your windows, if you have mold and mildew anywhere in the house, this is really related to a moisture problem. If you have uneven heating in your house, if you have rooms that in the wintertime, some rooms are cooler than normal, and some windows are warmer than normal, you don't have even heating. If you notice that you have drafty areas in your house, and obviously if you have high energy bills, these are the kinds of issues that home performance contractors and home performance approach addresses. And the last but not least is carbon monoxide and backdrafting. As long as you have a combustion appliance in your house that is burning a fossil fuel, that combustion appliance is capable of making, under the right conditions, of making carbon monoxide. And every year there are stories that you can find, and nationally in the press, of people who are killed in their homes because of faulty combustion appliance equipment. And that could be a furnace, it could be a water heater. In fact, water heaters have actually accounted for people's deaths in houses due to carbon monoxide poisoning. So this is the approach of home performance, and we're going to get into a little more detail. Next slide. Next slide. Thanks. Real quickly, just notice the house with the icicles hanging down. Icicles in my business traditionally have been the best friend for an insulating contractor because it was the clearest indication of heat loss out of the house, and we could use icicles as a diagnostic tool to show people that there was heat leaking out of their houses. We haven't had so much of it because the snow load seems to have been declining over the last few years due to climate change. But if you are interested in better control of the humidity in your house, if you want to reduce ice dams, we're not completely done with snow in central New York. I guarantee we will have snowy winters going forward. If you want to reduce street noise from the outside, most people don't think about it, but getting your house insulated and treated actually will do that. And finally, reducing infiltration of pollen, insect, and pest intrusion. Insulation air sealing accomplishes that. Next slide. Next. Okay, so it starts out with an energy assessment, and it really is about what you're trying to do in your own home. The contractor will discuss the issues that you have in your house. They will then inform you of the solutions to your problems. This is not about selling stuff. This is about solving problems. And everybody, when they think about their house, if they think long enough and hard enough, they realize that there are things in their houses that are not working really the way they should. And this is what a home performance contractor will address. Then they will provide the data that you need to properly size the heat pump system that will be installed, and will deliver some proposals. It is not uncommon, by the way, for people to get their houses insulated, leave their existing heating equipment in place, and then that equipment becomes oversized and then becomes less efficient because it's not working properly to fit the needs of the house. Next slide. Okay, so what you have going on here is that one of the primary tools for a home performance contractor is a tool called the blower door. And in the simplest concept of it, it's nothing more than a really big fan that mounts in an outside door in an airtight shroud. And when that fan is turned on, it pulls air out of your house. And so it creates a little mini vacuum in your house. It's nothing like you're going to see things flying off your shelves, but it's enough to actually show where air leakage. If you do a quick click. So as the fan turns on, you'll notice, click again, that the fan actually causes wherever air is leaking out of your house, when the fan is turned on, it reverses that and it shows the air leaking in. And if you have an infrared camera, you can visually see where the air is leaking. Now, to give you an idea of what is going on here, there are 3 photographs. This was done during the summertime, and it was done in the top floor of a building. So what's above that ceiling is an attic space. And in that attic space is really hot air. So in the upper left-hand corner, you'll see the house as it looks normally. And if you look at the lower left-hand corner, you'll notice that there's a little bit of kind of light-colored line above the window. But when the blower door is turned on, you can literally see that the hot attic air is being drawn into the interior wall of the house. What looks like icicles hanging down is actually warm attic air that has been sucked down into the interior wall cavities because of air leakage going out the top of that wall. There are literally gaps at the top of those interior partition walls. In the wintertime, under normal conditions, when the house air is warmer than the attic air, that process takes place in reverse. And warm house air is leaking 24 hours a day, 7 days a week through these little gaps and cracks that are in the top, literally in the top of the plates of the top of walls of every single one of your interior partition walls. And that is probably the largest single source of heat that generates the ice dams in your attic. Next slide. So how do we do that? Well, if you have a hole, you fill it. If you have a gap, you seal it. You'll notice you just simply, the home performance contractor will go into your attic, and what you need to notice is that this is an attic that already has insulation in it. And what you need to know is that insulation, blown insulation or fiberglass insulation, will not stop moving air from leaking out the top of the house. They act more like a sweater on a windy day or a sweater on a calm day. They will keep the heat in, but they're also like a sweater on a windy day. They don't stop air from moving through it. So a home performance contractor will caulk around electrical boxes. They'll caulk electrical penetrations. They'll caulk the top plates of walls. There are many that are holes that are in the structure of your house that you will never see unless you're in your attic on your hands and knees crawling around. There are pipe penetrations, and chimney penetrations and electrical penetrations. There's many, many holes, and the home performance contractor seals them up. Next slide. So after that's all done, there's insulation. And depending on the exact circumstances of your house, it could be spray foam insulation on your roof deck, or it could be blown insulation in your attic. And finally, one of the major places of air leakage that people never even think about is in your basement, on top of your foundation walls, where the joists sit on top of the foundation walls. That is a major air leak location. If you think about the very first slide that Lindsay put up, you'll notice that there was warm air leaking out the top of the building. There's also cold air at the same time leaking in at the bottom of the building. And that leak point at the bottom of the building is in the rim joist, which is the foundation structure sitting on top of your foundation. So a home performance contractor will seal that up and insulate that also. Next slide. Okay, ventilation options. Once a house is all tightened up and sealed, it's going to get tight. The intention of the work is to make it tight, but it is really critical that your house has the ability to breathe for indoor air quality. But the difference is, instead of it breathing uncontrollably through air leaks, it can be breathing based on a calculated amount of fresh air being drawn into the house through mechanical ventilation. And so what it does is, instead of just leaving the house tight, the contractor might recommend everything from a really high-tech, incredibly silent and powerful bathroom fan that is properly vented to the outside. Now I'm sure you may have fans in your bathroom ceilings, but they could be of low quality. If the venting is not properly designed, they literally won't move the air they're designed to move. But the home performance contractor can do it and literally install the proper bathroom fan that can be run literally on a timer, so that during the day it runs a certain number of minutes every hour. That creates a little vacuum in your house, which creates just enough air leakage, remaining air leakage, to create comfort. On the high-tech side, there's what's called a heat recovery ventilator. And that's what that is that if you look at that box you're staring at, you'll notice there are 4 ducts attached to that box. And what that does is that is an active device. You click on it, usually mounted in the basement. What it does, it's kind of like magic. It literally brings in outside air, and I don't have control, but if you'll notice at the bottom, it says fresh air intake at the outside at the bottom. It brings in outside air, and at the same exact time, it takes stale air from the house, which is at the bottom on the left, and removes it from the building. Now, if all you did was blow outside air into the building in the wintertime, your house would get cold. But what a heat recovery ventilator does is that as those 2 streams of air pass by each other in that little diamond-shaped box you see in the middle of there, that is a heat exchanger. And the heat from the air going out is actually transferred into the fresh air that's coming in. And so by the name of it, it's a heat recovery ventilator. They operate around 70 to 75% efficient. So it's a way to literally bring fresh outside air actively into your house and not have a big energy penalty. They also work in the summertime, because in the summertime, but when the outside air is hot and the inside air is cooler, the same process takes place, and they will actually transfer the incoming hot air to the outgoing house cool air. So they work year-round to bring fresh air into your building, and they are considered to be the state-of-the-art in ventilation systems to improve indoor air quality. Okay, next. I'm done. Thank you.
Thank you, Dick. So I've mentioned already that there's financial incentives available, and I'm really excited that not only are there essential incentives for low to moderate income households through the Empower and the Assisted Home Performance programs now, there's a new program called Comfort Home that's for market rate customers, the people who don't qualify for the low income ones. And so across the board, there is financial assistance to help improve the home performance of your home. So for people who are below 60% of the area median income, there's a $7,000 grant available from New York State that goes through the contractor. It comes right off the top of the bill. And Empower recipients can also qualify for assisted home performance. That's available for people who are at 80% or below the area median income. It's a $4,000 matching grant. So if you put $4,000 towards insulation or air sealing work or energy efficiency work, the state matches that with $4,000. You get up to $8,000 worth of work done. Assisted home performance can be used in a number of circumstances to install heat pumps as well. Just keep that in mind when we talk about heat pumps. And then with the Comfort Home program, the amount of the grant depends on the amount of work that you're doing in the house. So if you're just doing some basic air sealing, it's $500. If you do air sealing and insulation and a few other things, then you get $1,000. It's at different levels depending on the amount of work being done. So through all these, the installers, you have to work with particular installers. All the installers that do home performance in our program, SnugPlanet, Halco, and Simply Installs all work for all these programs. We'll go forward from here and talk about heat pumps. But this is the place to start. Before we start here with energy efficiency, because before we talk about heat pumps, we want to talk about how we reduce the energy use in our house overall in terms of heating, because so many of us, upstate New York, it's a relatively safe place to live. We don't have a lot of natural disasters that take out our homes. We have a lot of old homes up here. And so that means that our homes were designed for the technologies of 200 years ago, 100 years ago, even 50 years ago. And so they tend to be colder than we want. They tend to be more energy intensive than we want. So once we've snugged up the house, then we talk about heat pumps. So what the heck is a heat pump? Some people may be familiar with them already, but we'll go for the basics. So most heating systems burn fossil fuels to keep you warm. That's all the fossil fuels and also electric, you're basically burning electricity to use resistance electric. But what heat pumps do is they use a smaller amount of electricity to capture the heat that's around us in the environment. Even in the winter, there's heat around us. In the ground's usually at a stable 45 to 55 degree temperature. Even in the air, there's energy when it's cold. The only time you don't have energy in the air when it's cold is if you are at 273 degrees below 0 Celsius, which is 0 degrees Kelvin. And it doesn't get that cold in upstate New York. So heat pumps, they work to capture the energy around us and they transfer it into the space that we want to heat up. And it goes through a process through the heat pump to pump up the temperature that you want into the house. And so, again, we've already talked about the climate impacts of our fossil fuel use. Heat pumps help us reduce that. Energy costs, 40% of New York heats with fuel oil, propane, or electric resistance, and all of those are very subject to dramatic fluctuations in price. Right now, we've seen oil prices crash, interestingly, but that's not going to stay the case forever. And who knows what it looks like coming out of the end of this crisis of coronavirus. So heat pumps can help protect against the fluctuations in the energy costs. They also improve home comfort. Whether we're talking about geothermal or air source heat pumps today have variable speeds to them. And so they basically keep the air in your home moving just a little bit in order to help, basically just put in the amount of heat that you need at a given moment. So people are finding that homes with heat pumps are much more comfortable because it's just a much more even temperature across the whole home. And you don't have the on or off of a normal, say fossil fuel heating system where, you set it at a certain point and it's either all on or all off. So then it decreases to a lower temperature, you get cold, and then it finally kicks back on. And then one of the things that we wanted to talk about was the importance of air quality right now. And so heat pumps eliminate the combustion in the home, which is a source of air pollution in our homes. And that results in better indoor air quality. Now, I am not a doctor. This is not medical advice. But as we've all been trying to wrap our heads around the current crisis of coronavirus, there's been a lot of information coming out. And one of the key pieces that we keep seeing is the link between air quality and respiratory health. And this is somewhat of a no-brainer. We've already known in terms of if we have poor air quality, our lungs are already starting from a point of not being able to deal with whatever comes at them. It makes you more prone to illness. And so there's some research out of Harvard University that's been looking particularly at long-term exposure to PM 2.5, which is particulate matter. And they're finding that it leads to a large increase in the COVID-19 death rate. So I wanted to take a look at, what's the sources of PM 2.5 in our homes? And that really is the combustion sources in our homes. And that can be everything from candles and incense to our fossil fuel furnaces if they're not vented correctly. It can be our cooking appliances if we're not using the vents. And so this comes from the EPA of just a couple of recommendations. I want to just put this out here for everybody right now because there's things we can all do to improve our own indoor air quality at this given moment. And the key thing is, of course, venting, not creating more particulate matter in your house as much as possible. Wood, coal, those are high sources of particulate matter. And again, if your heating system is not properly vented, if it's not going outside in an efficient way, if it hasn't been tuned up or checked, this is a good time you might want to do that. And of course, change your filters. Many of us are guilty of not changing our filters as often as we should. And so regardless of what your heating system is, if you have a system that has filters to it, which people who have hydronic systems, radiant heat, they don't have filters on those systems. But if you have some system with filters, change them. Introducing air source heat pumps or ground source heat pumps into a home, particularly air source heat pumps, if you're using that to, say, supplement the use of oil or propane in your house that goes to power or, heat a hydronic system, you then get air filtration in your house finally. And we can talk about that a little bit more. So I've been throwing out words here and just want to give a brief overview of, when we're talking about various kinds of heat pumps, we're talking about air source heat pumps, cold climate air source heat pumps, which are good for space heating and cooling, ground source heat pumps, which are good for space heating and cooling. Ground source heat pumps can also be used for water heating. And then there's heat pump water heaters that are available as well. And the heat pump water heaters are using air source, so those are used for hot water heating. And right now there's a lot of incentives in play, and there's new incentives. So people who've been part of the HeatSmart program, I want to really highlight that the incentives have changed, but they haven't changed dramatically. And the best way to describe it is that they've changed the way that they measure the incentives by measuring by the heating tons to measuring by this, basically promoting the higher incentives for the systems that work best at the coldest temperatures. So that's actually an improvement in the incentive systems. The incentives have now gone to be utility rebates. So instead of going through NYSERDA, they are going through the utilities. It means that the utility rebates that existed previously have gone away, but it's all packaged together now in this one system that the contractors will help you access. They actually will do the application process for you. So it means that there's generally more money available for heat pumps. For cold climate air source heat pumps, the new utility rebates are $1,000 per 10,000 BTU hours of the system at a NEEP rated 5 degrees Fahrenheit. NEEP is the Northeast Energy Efficiency Partnerships. This is really promoting using the most efficient systems. And then for ground source heat pumps, it's $1,500 per 10,000 BTU hours. Heat pump water heaters, the incentive on heat pump water heaters has raised dramatically to $700. There's still a federal tax credit on geothermal. We have an affordability grant for homes that are in the low to moderate income category. And if you're wondering if you are, please do look at our website. If you qualify for HEAP, you definitely are in that category. If you don't, you may still be eligible for the assisted home performance. On our website, heatsmartcny.org, there's a financial help page, and it goes into what those income limits are. And then the new thing is that the new incentives actually are available not just for residences, but also commercial buildings, municipal buildings, and even large commercial and industrial. For systems that are larger, and this, 135 BTU hours is much larger than an average home, the incentives are calculated on the BTU savings. So even for new buildings, you can make a calculation about how much energy you would use under conventional systems, and then what a new system would be, and make these incentives. So I want to put those numbers out there ahead of time before we talk about the actual technologies. So I like this video from NYSERDA. And, oh, interesting, it doesn't work right now. Oh, okay, well, this is where we learn that webinars have their downsides. This will be entered into our actual webinar. So ducted heat pumps, so air source heat pumps, and I'll go to the next one. They are pulling energy from outside the house. Even at really, really cold temperatures, 13 degrees below 0 Fahrenheit, they work. And those are cold climate air source heat pumps. You can have ducted and ductless systems. This is pictured here is a ductless system. And so it is basically using refrigerant lines that go between the outdoor unit that captures the air temperature and goes to the indoor unit. And so it goes through a heat exchanger. And so it's basically it's a refrigerant loop. It's like, so heat pumps, everyone has a heat pump in their house. It's called your refrigerator, actually. And so this is basically using that same technology, only it can also work in reverse to heat your houses. And so you can see here, here's some examples of the indoor units available for air source heat pumps. You can have ones that are mounted high on the wall like this. You can have ones that are mounted lower on the wall. And there's also ones can, as I said, they can be also ducted. So you can actually have them in your ductwork as well. Here's an example of a system that was installed through HeatSmart CNY in this house. And just give you a sense of the costs. So this was a multi-zone ductless heat pump system with 2 outdoor units and 4 indoor heads. And at that point, there was only just the NYSERDA rebate that they went for. And so that reduced the cost down to $14,000. You know, if you're looking to replace your heating system and air conditioning, you're looking at about $9,000 of cost right there already, depending on the size of your home and all of that. So it's not a big leap to make an investment in your energy future. And they did extensive insulation and air sealing in the house as well. This is in Cuyahoga County. And then so for geothermal systems, ground source heat pumps, again, it's a similar thing. So you have the ground loop that goes out to the ground. It's at, as I said, the ground is at an average 45 to 55 degree temperature all year round. And so the ground loop, it's just food grade glycol and 5% of that in water. And so that goes out, it captures the temperature of the ground, brings it in. It goes through the refrigerant loop, through the heat exchanger. And so it transfers that heat to the refrigerant. When a refrigerant expands at a very low temperature. And so that expands. And when you then compress a gas, which is what happens in the heat pump, it then, when you compress gas, it heats it up. And so that's how you create the temperature in your house. So then it goes to the distribution loop in your house. For geothermal, that can be air ducts for heating, cooling, or it can be the hot water pipes for radiant heating. Now, if you currently have a boiler system, you may need to add some additional distribution in terms of radiant surfaces, particularly if you're at a high temperature radiant system, so like one that depends on about 180 degrees Fahrenheit. If you are using just radiant floors, those are usually a lower temperature system, and so a geothermal heat pump system, a water-water system would be a great solution there. So here you can see kind of what they look like. It looks like a very pretty furnace in your basement. And they last longer. That's the really important thing to remember, because they're not, all the heat pumps, they are not subject to the same extremes of temperature that combustion systems are subject to. So it's much more efficient, they last longer. Ground source heat pumps are, because they're protected from the elements, both the outdoor loop is buried in the ground, and then the indoor system is in the basement. It also lasts longer than air source heat pumps. So you can see here, we're talking about two kinds of loop fields. In areas where you might have a smaller space, you can have a vertical loop. It goes down up to 499 feet down. Sometimes you might need to do multiple wells if your house is very large. Or you can do, if you have a lot of room, you can do a horizontal loop field. And here's just the tubing that goes out there, and that's the heat exchanger. Or that's the heat exchange with the ground, rather. So here's an example of a home in Jamesville. They did a geothermal system. They did a 4-ton geothermal system. They got the NYSERDA rebate. And so here you can see a bunch of the incentives piling on right now. So that dropped down to about $31,000 the contract cost. And then when you factor in the 30% federal tax credit and the national grid rebate that existed at that point, they brought the whole total down to $20,000. The geothermal rebate for the the federal taxes, that's dropping from 26% to 21% at the end of this year. So it's important to try to capture that. It was 30% last year, so you can see it's decreasing over time. So one of the reasons why we want to, even while we're all on pause, still educate people about heat pumps, because this is still a good year to look at your options and install something. One thing I want to highlight that we're running into with a lot of homes is that a lot of our homes don't have adequate electric service. These systems do require a higher amperage, and so having your electric service upgraded is also a key piece of this. Again, there's insulation and air sealing work here, and they also installed solar panels. So and we've seen this in a lot of houses. A lot of people whose houses we've toured, they've been people who are generally around retirement age, who are trying to control their energy costs into the future. And so they're pairing a geothermal system with a solar panel system. And so the solar actually covers most or all of the energy that's needed to heat the house, which is a really neat solution going forward. It does require an upfront investment, and I realize that in these times, these may look like really large numbers in a very uncertain time. I totally understand this. That's why I want to be upfront about the numbers. Some people might be able to handle this. Others may have to think about it for the future. That's understandable. So comparing some of the systems. So air source heat pumps, the efficiency, and when we're talking about efficiency, we're comparing it to baseboard electric. So that's 100% efficient. For every electron that you're putting into it, you are creating 1 unit of energy. Our combustion furnaces, they're only 96, 98% efficient at best. Air source heat pumps are 250% efficient, because for every unit of energy that they're using to run the system, they're capturing another 2.5 units from the environment around them. Ground source heat pumps capture 4 units of energy from the environment around them. So one of the questions we often get is, so I have this heating system, which systems can I use? Ductless mini splits are complete into themselves. They're a really good retrofit situation. Ducted versions, of course, are available too. I kind of covered this in the last piece, so I'll just skip that. Both of these do provide air conditioning. If you have a hydronic system, you we'll have to add an air handler to create some air conditioning if that's what you're going for. Not everyone does. A lot of people just keeps their house just for the heating, for the geothermal for the heating. So for zonal control, for a mini split system, each has its own zone. The ground source heat pumps zoning is an extra feature, but that can certainly be built in. Average lifespan of air source heat pumps are, you're looking about 15 years, same as the normal furnace these days. Ground source heat pumps, you're looking at about 25 years for the equipment and 50 years or more for that ground loop. It's just plastic in the ground. It's protected. As long as you don't dig into it, you're good. A couple of considerations: weather sensitivity. Air source heat pumps, you need to make sure that the outdoor unit does not get buried by snow. So you want to raise it up in areas that get high snow levels. Geothermal systems, they run fine. The other thing to know is that the disturbance to the ground for a geothermal system is extensive when you first put it in. And you know, the contractors will put it back to a grade, but you'll need to do some landscaping. For air source heat pumps, the disturbance to the ground is minimal. And yeah, there's incentives. So here's another, so for people who are on natural gas, you might be thinking, what do we do? I fought fracking, and so I come from a place of we want to eliminate natural gas use as much as possible. That said, natural gas costs are really low right now because they're not accounting for the full impact they have on the climate or on pollution. That will be changing with the Community Leadership and Climate Protection Act. We are going to start accounting for the full actual cost, societal cost of natural gas. For right now, I have been impressed with these dual fuel systems. We've had a number of people in the program install them. And this is a good example of a low to moderate income household. They actually went through a program, did the energy efficiency. They're looking at just getting insulation, and discovered in that home performance analysis that their furnace was actually leaking high levels of carbon monoxide into their basement. So it was a family with young children. It was actually a scary moment. So this winter we were able to get their system replaced with a high efficiency gas furnace that was covered by the Empower program. And then they used, they were able to use assisted home performance to some degree to then get a cold climate air source heat pump. And so now their system, their house is basically what I call future-proofed. So the benefit of doing a dual fuel system is that as energy prices change, and as your appetite for reducing your carbon footprint changes, you can set what the changeover point is. So this house is changing over their temperature, basically from the air source heat pump to the gas furnace at 30 degrees. And they could set that lower, they could set that higher, but it's gives them that choice. And so if we do see natural gas prices spike in the future, they'll have the air source heat pump to fall back on. And the cool thing is they have saved over 1,000 pounds of carbon dioxide in the past month that this was installed. There's also heat pump water heaters. So this gets at our water use. And so these are neat. They're basically like an electric water heater, except they've got this unit on the top. And it's actually capturing heat from the air around it. These are great in unfinished basements. You don't want to put this in a closet situation. You don't want to put this in where you have a living space where you're right next to it, because the top unit it's louder than your average water heater. But it's not terribly loud. And what it's doing is it's capturing the energy around it and using that to pump that heat into your hot water. And so it's 2.5 times more efficient than the electric water heater. And they also provide a small amount of dehumidification in your basement. Although if you have a very wet basement, you're going to want a dehumidifier anyway. And so looking at the fuel costs to give you a sense of where things are, and these are the 5-year average costs, these are not current costs. I'm going to give that caveat. I have no idea where the energy costs are right now because it seems to be changing every day. But electric resistance is usually the most expensive. And propane is also very expensive. Oil is expensive. Gas, again, is the cheapest at the moment, but it is subject to fluctuations. And then you look at the cost to operate air source heat pumps and ground source heat pumps, and it's actually very efficient. And I wanted to give you some examples, just thinking about larger systems in the area. So there's a lot of places that have actually installed geothermal systems already. Auburn Memorial City Hall has a geothermal system, the Marcellus Library. The Food Bank of Central New York, in their warehouse, it uses a geothermal system. The Pike Block in downtown Syracuse, and the Schiedemann Science Center in SUNY Oswego. All of these run on heat pumps, geothermal heat pumps, to heat and cool their buildings. And some examples of air source heat pumps in Central New York. The Sinclair on Skinny Atlas has air source heat pumps. The Hamilton Fire Department has heat pumps, which seems appropriate. Fire departments probably don't like, I mean, we know fire departments don't like to fight fires, so eliminating combustion in their own fire barns makes sense. And then the Preble Town Hall also has both air source heat pumps and solar to keep them running. And then this is the Town of Hamilton Municipal Garage. This is a geothermal system that just went in. The expected annual savings on this is nearly 7,000 pounds of carbon dioxide and $7,000 or more of energy costs. They installed, it was a 10-ton system. They're using it to heat the shop area, which is a very large cavernous space. It's a water to air system. Sorry, I got distracted by the chat. And they were able to finance this. It ended up costing the town only about $15,000 because they did this through the Clean Energy Communities program, which Amanda Bizzoni, who's part of our HeatSmart campaign, she manages to help municipalities look at how to become more energy efficient. And so they got a $50,000 grant from NYSERDA. They fundraised among people of the town for another $12,000, and they ended up paying only $15,000. So this system is going to pay for itself in 2 years. And that's one of the reasons why we wanted to highlight commercial and municipal buildings at this point, because this is a good opportunity, particularly as we're thinking about our recovering economy. Where can we invest the money to help with local jobs and also our energy efficiency going forward? And so I've basically gone over this in some of this. Heat pump water heaters are in around the $3,000 range. Incentives can be used to help pay for them. Ground source heat pumps, they can be quite expensive. But there are incentives, and with the tax credits, with the incentives, we're seeing the costs come almost in half for geothermal systems. So it's a really good time if you're inclined to go that way. A single air source unit. So if you are on oil or propane and can't afford to do a whole home switch right now, we've had a number of people in the program just install a single one-to-one indoor unit, outdoor unit head system. So it ends up being about $6,000. It's only a $500 rebate right now for those because they're not addressing the whole home. But you can use that to basically decrease the amount of fossil fuels that you're using and decrease your costs. So the way that this program traditionally has worked is that, so first of all, I'm here as a resource. Dick Kornbluth is here as a resource. You can catch us on our social media and on our HeatSmart CNY hotline. I'll go to that in the next slide. We have, right now, as I said, our installers cannot come into people's homes because of the New York State pause. When that's lifted, people will be able to come into their homes. They're using, they have masks, they're avoiding, they're doing the social distancing. Often they're working only in our basements. So there's a lot that's being done to make sure that people stay safe when things are lifted. In the meantime, they can do virtual assessments. They can help you explore the options for your home. They can hear what the problems of your home are and give you a rough estimate. And so then once everything's lifted, they'll do in-person assessments and give people solid quotes for their homes about what they can do to improve energy efficiency. It's a no obligation quote. This is information for you. This is the way we learn how we can improve our energy efficiency going forward. So our installers, we have 5 installers in the program now. You can see that Halco Snug is simply installs, do home performance. ACES, Halco, and MP Environmental specialize in geothermal heat pumps. Everyone does air source heat pumps, although I know ACES prefers to focus on the geothermal, and everyone can do heat pump water heaters. And again, we are one of many campaigns, so if you are in any of these areas, feel free to reach out to the campaign near you.